Well, again, so right now we are tackling another problem. It's called DivisorInc. It's my first time reading it, so let's get started. So it says that there is an integer k. You are allowed to add to k any of its divisors not equal to 1 and k. The same operation can be applied to the resulting number, and so on. And you notice that starting from that number 4, you can reach any composite number by applying several such operations. So for example, with the number 24, can be reached starting from 4 using 5 operations. Okay. For you will solve a more general problem, which is given int n and m. Want to return the minimum number of the described operations necessary to transform n into m, and we want to return -1 if m can't be obtained from n. Okay. Okay, let's try to just draw up this problem and see and try to understand it. Okay, so I have my iPad here, and I'm going to try to draw the problem up to understand it better. So it says that we have an integer k, okay, and we are allowed to add to k any of its divisors. So we can have, if we have a divides k, then we can add that divisor to k. So add to k any of its divisors not equal to 1 and k. So this a here has to be different than 1 and different than k. Okay. The same operation can be applied to the resulting number, and so on. And then once we do this, once we add it, we can apply the same thing again. So we can recurse and apply the same let's say, operation again. Now notice that the starting from the number 4 can reach any composite number. So composite number, it means so if we have prime numbers, and any numbers that isn't prime, it can be divided by some other number less than it. That is a composite number. And so we notice that starting from 4, we can reach any composite number by applying several such operations. So when we start from 4, given another number x, we can reach any composite number by applying these list of operations to 4, and when we apply these, we get x. And our example here is x equal to 24. So the example that we have here is we add, so we have, for example, 2 is the divisor of 4, and so we add it, we get 6. And for 8, we have, let's see, 2 again. So 8 is a divisor to 6, so we add it. We have 4 is a divisor to 8, and so we can add that, and we get 12. And we have 18, which is a divisor, so we have so 4 is a divisor, let's say 6 is a divisor to 12, and so we can add 6. And from there, 6 is a divisor to 18, so we can add that again. And with that, we get 24. And so we want to solve a more general problem, so we would get as input n and m, and We want to return the minimal number of the described operations necessary to transform n to m. So we want min operations so that we can get n to be transferred to m. And we can just return -1 if we can't. Okay. And this is the signature of the function. And so these are the constraints that we have, and we can see a couple of examples. For 4 to 24 we had 1, 2, 3, 4, 5. So we have 5 operations, which are the arrows that you see here, which are the arrows that you see here when we do the numbers. So 1, 2, 3, 4, 5. So we had to do 5 operations to go from 4 to 24. Let's take another example that was given in the problem. So from 4 to 50 to 576, it takes a little bit more, so we can have, let's say, I'm just gonna do a part of it, not everything. So from 4 we can go to 6 by adding 2, we can go to 8 by adding 2, which divides 6, we can go to 12, which is by adding 4, and we can go to 18 by adding 6, which is divisible to 12, and we can keep going and go to 27 by adding, let's say, 9, which divides 18, and we can just keep going until we reach 576. And the example given in the problem, this gives a total number of 14 operations. And that's the gist of the problem. Now let's think about how can we solve it. Now let's think about how can we solve this problem here. So we know here that we have a list of operations that we need to keep somewhere, right? And we know that we need, so let's just list the information that we have here. So the problem that we want to solve is having n and m, right? We want to go from this to this. Let's think just about if we were to do this in the most brute force way, and we want just to obtain the minimum. What can we do? Maybe we can just do the greedy approach where we want the minimal number of steps, which means that we can just pick the highest, let's say, the highest divisor each time, and just go with that. But just remember, we need to remember that we are allowed to add to k any of its divisors that in itself. So for example, for 4, we can say what is the highest divisor? It's 2. So we know we need to add 2. So we get 6, and at 6 we ask what is the highest divisor of 6? We know that we have 2 and then we have 3. So let's say we choose 3. Already you can see that it's different than the example given. So let's just list them simultaneously, the 2 possible ways. So the other one is 4. We can just do 2. but here we have two options. We can do either 3 or we can add 2. Okay, we can add 2. So here we get 8, right? We get, adding 2 here we get 8. Adding 3 here we get 9, right? Adding 8 we get, adding 2, sorry, we get 8. And then we can continue. Here we have how many options. We can add 4 or 2, whichever one we want, but the highest one is 4. So let's see here how many we can do. So here we can also do, just to simplify things, I'm going to go for this example, just go from, let's say go from 4 to, let's just do 12 and see how can we do that. So from 8 we can do either 4 or 2. So let's say here we do 2. Let's say here we do 4. So if we do 4, we get 12, right? If we do 2, we get 10 here. If we do 9, we have the option to add 3. Or we have the option to add only 3, actually 3 or 9 itself. 9 we can add it, so we have to use 3. So if we add 3 though, we will get 12, right? And so here with 10 we can add another 2 or 5, right? 5 is bigger than 12, so we don't need to go there. But you see here we check if bigger. That's important to remember, because we will need to do that in our algorithm. So if 5 gets us like 15, then this is no good. We don't need this. But for 10, if we add, let's say 2 again, we get 12. Now if we count the number of operations we get here, so for this path here 1, 2, 3, so we can have here 3 operations, 1, 2, 3, here also we get 3, and for this 1, 2, 3, 4, this one is 4, so this one is eliminated, so we can pick one of these 2. So yeah, this is a way to obtain it. Now let's see if we can make a general algorithm from this. So from what we have here, you can see something interesting. What we are doing is we kind of have different paths and we are choosing the shortest ones, right? So once we do this, we can figure out that we can just transform and build a graph where vertices are numbers from n to m, from this n here to m, and the edges are just the operations from that the problem statements describes. So any divisor that is not the number itself or 1, that can constitute an edge. And to solve the problem, we can just constitute, you can just basically just calculate or find the shortest path to get from the number here to the number that we want. Okay. And to find the shortest path here, we can just use BFS. And basically, so yeah, that should solve the problem. Code the problem that the solution that we just discussed using DFS to find the shortest path. So I'm going to code it this time in C++. So let's start. I won't need this, so let's delete that. So what we will need is the function signature, and let's add a class here. Okay, so let's try to get our DFS going here. So we have a queue. So let's include it. Actually, to get rid of that, let's try and we need something to compute the distances, so let's do a vector of int, say distance from so let's give it this size, and let's initialize them all to -1 first, and from there let's so we will need to push first the starting point, which is n for our case here. So that will be the value that we get given for example, for this case here, from 4 to 24. And from there we can, so we need to push that first. And also for n, which is our starting point, we would have a distance of 0. And yeah, let's continue our DFS. So while our queue is not empty, we can just get the value from the queue and check if we reached m, because we don't want something that is divisible by m, so we can just stop. So that means if value reaches m, we can just break. And we want to go through every divisor of, basically every divisor of the value here, of the value that we got from the queue, so that like I showed in the drawing earlier, so that we can like compute the distance, so that we can pick the shortest path. So we need something that gets us the divisor of the divisors of a number, so that would be getting divisors of value. So let's just create this function. Yeah, I prefer them always to be, this one needs to be public for Topcoder Arena, and we can just have this function here that we want to return to us, let's say, all the divisors of that value there. So a vector of int, and so let's construct it first. And from there we can just go through like all like go through all the numbers less than m, less than the value that we have passed in, and basically push it. So push all the divisors in there. So what we can do is, of course, since we can just start from, let's call it D, start from 2, and what I'm going to do though, I will explain this later, but what I'm going to do is just I'm going to start from a stop when I reach the square root of value, and so check if it's divisor, if it divides our number. So if val is divisible by d, then we can push that number into the list of divisors. But since I did here square root of value, so that means that if I find a divisor, that means that, so this is just an optimization, because if I find a divisor that is less than this square root, I know that there is another divisor of that one, and that one would be obtained just by doing value divided by the divisor itself. So this is a very nice optimization there. So we can just add, if we find a divisor, we can just add the other one, the other value basically, which would be val divided by d. Okay, and from there we can just return a list of divisors. Okay, so once we do that, we can go back here. So now that we have the list of our divisors, we can just go through them. So let's say for int d in the list of divisors, what we can do in this case is pretty simple. So we can say we can continue basically our, so divisors are like neighbors in a graph. Okay, so these are you can consider them neighbors. So we can do our DFS. So that means there is though a constraint of having a path between two numbers. So one of the constraints is that the value plus the divisor itself has to be less than the latest value, because we need to stop once we reach m, and also the distance has to be equal to -1, which means, because we don't want something that was already found. We don't want, so from 4 to 6 we don't want to have +2 path 2 times. That just isn't necessary. So we can just say val plus dist plus d should be equal to -1, and from there we can just add that to our q, because that's part of the path that we want to find the minimum of. So we can just push that value. I'm going to just call this value new path, or let's call it path value, something like that. And so we push that, and that means that that distance now becomes the distance of the previous value plus 1, right? So that's the counting of the number of paths in the graph. And once this is done, basically we can just return the last one, right? So we can just return our last distance that we found first, right? Because so this is cool, because if the as I showed in the example, the one that has more paths, like, it will be found later. So
this one would be found first, and we can just return it. Because of this check here of different than -1, that means if it's already been found, like if the m value like 12 was already found, we will not even get here, and the value that was found first would be the one that we return here. So yeah, that basically makes it done. And from there we can just let me make this one here private. And with this, I think we can try to run it. So let's try to run it and see what we get. Okay, now let's run this. Yeah, we just need to do a small yeah, I need to reload this. Okay, so we got 5, which is the result that that we have here. Now let's just go to Topcoder Arena here and try to submit this. Yeah, it's weird that there are two. One has more points than the other one. This might take a little bit while, so I'm just gonna end the video here, and yeah, that was the solution. Okay, see you. Bye bye.